There you go.
All right, sounds like a plan. Hope everybody's well tonight. So what we're gonna do is we're gonna talk a little bit about some of the options for building, as called building pieces and assembling applications in React. This is not gonna be a very slide heavy presentation. That is all the slides, because realistically, I just wanna kind of talk about code and talk through the pieces as we go along. When we talk about this, and when we kind of talk through these different options, what we're really going to talk about is the trade-offs every time that we make a choice. A lot of these different pieces you can find information on pretty easily. It doesn't mean I'm not going to demo them. I am, and we'll talk through them. But I kind of want to take it an extra step and talk about what's really happening behind the scenes and why we might choose one or the other, and what is actually happening when we choose one and what we're optimizing for. Like all things, when we go and start thinking about how to break up our application, we probably shouldn't just do it. Meaning there's a lot of advice out there in the world, especially when you get to these sorts of topics, that's all about you should do this, you should do that. This stuff's a lot more nuanced than that, meaning that for the most part, it is about what we're trying to accomplish. What is our goal in building things this way? What's our goal in breaking things up this way? What's our goal in any of this and what we're trying to get to? So I'm hoping today to kind of talk as we're going through this and discuss what the parts are and what the moving pieces are and what we're trying to do, so that not only do you walk away with how to do it, which I think is useful, but maybe you walk away with a little bit of why, and hopefully a little bit about what, and so really going on behind the scenes. So Bill had asked before about what to do about questions. Here's how let's take it for right now. If I say something that doesn't make any sense, go ahead and try and shout out and ask me about it. And let's see if we can handle it in line. If we can't, and if it seems like it's going to take a bit, or if it's something that's a little off topic, then what we'll do is we'll push it to the end and we'll see if we can get enough time to talk about it then. But if there's something that seems to be a little bit off, or something I say that I'm glossing past that's a little hard, try and interrupt me. Let's see what happens and let's just go through it. This stuff's fun for me. So to clarify, I really like talking about this stuff. I like getting into the nitty gritty of what's actually happening behind the scenes. So we're going to go through a couple different tools today when we go through this. And some of it's going to be kind of Webpack Config heavy, because we're going to have to talk a little bit about what's happening. But then what we're also going to do is we're going to look at sort of bundles and bundle analyzers and how things load. And we're going to talk a little bit about what's happening inside of the browser and why we're doing different things. So hopefully it'll be a little bit of fun. All right, so just as this. When we talk about breaking up an application, there's really three things in the world, and well, we're going to call it four possibilities. Number one, we build an application and we leave it exactly as it is out of the box, which is that it's one big chunk of JavaScript that we deliver to the browser and it runs it. And it's almost as though when you read stuff online that's looked down upon negatively, but I want to start out by saying that that's a completely reasonable choice. There are many, many times when we don't have to use any of the options I'm going to talk about today, because the small little version of the application we put together, or something that is, a few K, or, maybe even 100K, is just fine. It was kind of funny. I came through a period of web design where we really worried about image sizes and things. And now today, if you go to your average size of your web page, it's not uncommon to see somebody loading a 130K JPEG that they're downloading. So when we get to talking about bundle sizes for whole applications, we have to keep in mind what we're talking about. These sorts of options shouldn't be something we consider for something that's relatively small, for something that's maybe internal, for something that's loaded over an intranet. None of those are really big reasons that we have to split things up. The moment we start splitting things, we introduce complexity. And that complexity can totally be managed, and there's some really great ways to do it. But we introduce complexity, we introduce things that can go wrong, we introduce things that we have to debug and maintain. So first step, make sure that we know we want to do it. So that's one pivot, right? Which is don't do it at all. Now we're going to talk about these two more, which is bundle and code splitting, but it's a little bit of a false dichotomy. It isn't one or the other. These are the two techniques, but realistically, in any app that's large enough to actually split up into pieces, you may use a combination of them. So we're going to talk about them in terms of those pieces and what's one versus the other, but you're going to see very quickly, even in my code example, that I don't just use one or the other. I use both of them. So let's talk about why, though. And again, I tried to focus a little bit about why we're doing certain things. So when we get to Webpack, and this is specifically a little bit And these concepts exist elsewhere, but the standard these days and the things you're going to Google when you go out and look are going to mostly be Webpack and React. So this conversation is going to take place around Webpack and React a bit. So when we get to Webpack, we're going to see two options that aren't well understood. There's bundle splitting and there's code splitting. And they're presented as two options for splitting apart your code, and they are, but they're interrelated and they're not mutually exclusive. So first of all, bundle splitting is about separation of code, and I like to think about it as separation of code based on a frequency of change. What bundle splitting does, and this is probably the most important piece to come away from here, is that bundle splitting takes your code and it splits it into multiple pieces. All of those pieces, though, have to be loaded before your application can start up. So bundle splitting is breaking pieces down, bunch of pieces, they all have to be loaded before the application starts. Now, advantages and disadvantages of that. A, you have individual files, all of which now have to be loaded, so it doesn't seem like there's a big advantage of that. So a little bit of overhead as soon as we actually, very small, but a little bit of overhead as soon as we start splitting things up. So the big piece and the big reason that we actually consider something for bundle splitting is because of the fact that there's a lot of code in our projects that doesn't change very often. And although it is not thought of in terms of being quite so modern, really bundle splitting comes down to the mere fact that your browser's really, really good at caching things. So if we have a whole bunch of code that doesn't change very, very often, and it's going to be part of our application, then one of the first things we can certainly do is just make sure that somebody has, after the first time they visit, a lot of that code and they don't have to reload it over and over again. Interesting thing is that almost everybody, when you read a blog these days, because it's the newer thing and it's the cooler thing, jumps right to section 2, which is code splitting. And we are going to talk a lot about code splitting. But bundle splitting is probably the big side of the lever, right? When you get into an application and you're talking about how to make it advantageous for your user, bundle splitting is the probably most important tool you can do first, because it's about how I deliver code that somebody doesn't have to reload over and over again. And that's really important because we're optimizing for code sent and the code that we actually send over the wire. And the second piece that's really, really important there is that the advantage of that pattern grows as the amount of static code we have grows. Now you'd say, well, my code's relatively dynamic. Why would I be sending new code out if it's static? But you've got a bunch of dependencies. No modern JavaScript project is just the code you write. It's library upon library upon library upon library, which is all bundled up, which don't change nearly as frequently, at least likely, depending on what you're doing, as the code you're probably trying to deliver. So the odds are, if you make a change to an application and you want to deliver it to your users, your change is relatively small. Now, maybe there's some cascading things for libraries, but if you want to change a couple of bytes of code, you might want to deliver that to the user. But if they don't need to update every other dependency in the world, and we've split our code well, we can deliver a couple of bytes to a user and have them have a new application as opposed to delivering a couple megabytes. So bundle splitting is about separating the things in an application about the frequency at which they change. The things that change less frequently should be in different bundles than the things that change very frequently, okay? And then we are allowing the browser to do that. So we're gonna see a version of this and we're gonna play with it in a moment. Code splitting, on the other hand, is a pivot, but it's not opposite. It's orthogonal, okay? So they're interrelated concepts. But code splitting is basically the idea of saying, well, we still have to send code and that's really important, but maybe instead of sending all the code up front, we should send the code as a user needs it. And again, the tagline of this sounds great, right? If I was gonna write the headline, that would be the lead piece and it sounds wonderful. But the advantages or disadvantages of this aren't as clear. If we have a really large application where a given user does not or is unlikely to execute the majority of the branching paths in the application. So let's say we have a massive application and any one user is gonna, I don't know, see 5–10% of it in a day, then something like code splitting and lazy loading is a really big advantage for that user because they're only gonna load what they actually need. But if it's pretty likely they're going to see the whole application anyway, well, it's less of an advantage. It's even worse if they need a lot of it up front. Because the worst thing we could actually do is have something that we lazy load, but they pretty much need it all before they can do anything anyway. Because in which case, what we've done is we've gone through a lot of trouble and a lot of complexity and a lot of tooling in order to achieve something that's probably not a whole lot better. So remember, code splitting is about the idea of we can defer when a user gets the code if the user doesn't need all the code up front. Now, the subsequent advantage of this, which you'll see a lot of, is kind of important, which is anytime we send a bunch of code down to the browser, it does have to do some work. Depending on your browser, depending on the virtual machine that is running inside of your browser, it may not actually go through and do much with all that code, but at least needs to scan it, it needs to kind of parse through it, it needs to figure out some things when it arrives. So if we send it a huge chunk of code up front, it has to spend more time doing that. So the subsequent advantage that we'll talk about a lot, and again, your mileage varies because it depends on what you're producing with this, is that with code splitting, sometimes we can actually shrink the period of time until the page can render. And in certain applications, that's really, really critical. Like we care about those milliseconds. We care to get that period of time down to the smallest amount of thing before a user can see it. But again, make sure that's your choice and that's what you need before you do it. Because if we go through and spend a whole bunch of time shaving off a handful of milliseconds to be able to split something up, and it doesn't really matter to the user if it takes 50 or 100 milliseconds for something to load, well, we spent a lot of time for not a whole lot of good reason. All right, so that's me talking you out of doing all this, only because of the fact that I want you to make sure that if you undergo any complexity in developing something, anything that's going to make your life even marginally harder, that you understand why you might want to do it. So we'll go through and point out those pieces as we're going along, but it's going to be these two parts that we talk about quite a bit. And we're going to look at them with some tooling as well as we go along. So let's jump over to some code. I am going to say a thank you already to someone who I don't even know if made it tonight, but somebody at my office named Kyle, who was happy and nice enough to put together some examples for me that we're going to use, because we're going to use the obligatory to-do app because nobody has ever seen a to-do app before, and it is clearly the best way to execute and demonstrate every concept on the web. So we're going to use that tonight for something. But more importantly than the actual app itself, which we will go through, is we're going to jump into this thing that we're going to see, which is Webpack Bundle Analyzer. All right, so a couple pieces of terminology and things that were going on behind the scenes here. Whenever we are actually going to build something with Webpack in the background, Webpack is going to do some things, and these pieces that are interrelated are a little, they're a little mistaken or perhaps a little misphrased. So let's talk about them in terms of parts that come together. And for those of you who may have programmed in other languages, I'm going to provide some analogs that might help us think about it as well. So first off, most modern JavaScript is in some way compiled or transpiled, right? We type in something that's maybe ES next, it spits out in something else via Babel. All right, that's our compilation step. But what Webpack is it's referred to as a bundler. It also forms and does something a little bit, if you've worked in other languages, akin to linking, which means that it figures out what actually needs to be there and ensures that all those pieces actually come together. But we call it a bundler because we basically take something that's a bunch of individual files, and we, depending on how we configure it, we wrap it up into something that ends up being a bundle, or one or more, well, ideally, fewer JavaScript files than we started with. And we'll say ideally because we might play with that concept in a bit. So in a bundler sort of scenario here, what Webpack has done is Webpack took this application, which really just started as an index file and a little app and a couple of components, some to-do components and pieces like this, and it bundled them together. Now, in this config, which we're going to look at in a moment here, we asked Webpack just to basically dump everything into one big file. So that's exactly what it's done for us. It's split these pieces up individually, and it's internally made what it's basically our modules, which means internally it's made function closures that contain the individual pieces of code, but it's then bundled them all back together for us and produced one file that would be downloaded. And we would see this in a couple different ways. First of all, if we actually go through and load this thing up, we're going to see, and I'm doing this mainly so we have a benchmark for things in the future, but we're going to see exactly one main file load, which is going to contain all of our code. Now, these other things in here and pieces we'll get to in a moment. It's because I'm going to do a little bit more debugging as we go along. But what we can do is when we're working with Webpack, as I saw here, we can actually, or as we saw, we can actually look at the code it's generating, which is great. And if you can read this, this is your ultimate resource on everything that's happened inside of here. But Webpack also will produce something, if you ask it to, called a JSON file, which is often called stats.json. And stats.json will include all the information about how it produced those modules. So as we go through here and look at this, we can actually understand the decisions that Webpack made and how it bundled things together. This is governed by us telling it in this configuration file how we want things built. But the really cool thing about this is that when we produce something with this stats.json, we have the ability to use a tool called Webpack Bundle Analyzer, which will allow us to see how these things actually came together. So what I mean by that is to say, and now I need to move this out of here. By the way, the hard remaining problems in computer science are cache invalidation, where to put the zoom window, and bullet point lists. I believe those are firmly the things that will never be solved in computer science. Okay, so inside of our Webpack Bundle Analyzer, we can actually see how it built and what it decided to build together. So Webpack Bundle Analyzer will let us see how Webpack decided and allow us to navigate through all the different individual pieces. Now this whole socks.js thing, which you're gonna see a few times, and I might actually do something to turn it off, is because I'm running a Webpack dev server right now, which is actually gonna mean that there's a little bit of extra code so it can figure out how to do hot refreshes. But inside of main.js, we would dive there and we could see all of the individual pieces that I included. And while this is a little bit of information now, it's going to get really more interesting when we contrast it in a moment. So going back, right now, this application is really tiny. It has an index. The index just basically renders our app. Our app is a very simple little file, and it contains a couple of components, a to-do component and a little bit of local state. And all it really does when we get into here is that we can add a to-do, we can add some information, and boom, fine, we're good, right? No big deal, because we don't need a lot to actually demonstrate what we're trying to do at the moment. But this to-do app right now is all bundled together, so every component is going to live in this main.js, and we can see that if we look back in here, because main.js is the only file that we actually have. So at this point in time, we're talking about something that's been brought as one application and delivered as one application. Advantages. It's one request. It's the simplest possible thing. We send it down to the user. They have everything they need. It's all loaded together. We're good to go. Disadvantage, any dependency internal to it requires the full bundle to be updated and delivered. So anytime that we change something, everything has to be sent back down to the user. So the very first thing we can do, going back to my example, is that we could say, you know what? We'd like to actually break this up into a little bit to at least tease apart some of these dependencies. So let's go to here first and look at a base Webpack config that we're currently in here so that we can see the deltas. A lot of this stuff's not going to matter, so I'm not going to worry too much about these modules and rules. All this is really saying is that we intend to compile our React and we're going to do some HTML stuff, but I'm going to close that up for right now because we're really going to focus up in here. For right now, this bundle analyzer plugin is what is allowing me to see that information and to see the stats file. And there's no other information about optimization in here, and that's the thing that's going to change in just a moment, because we're going to see how we actually tell Webpack to begin optimizing for these other pieces. So let me close some of these down really quickly and go back over here. This, in my little version here, is exactly the same app, so we have the same pieces. But what we've done is change one important thing. Inside of Webpack's configuration, while the rest is really the same right now, we've added this optimization node. And this optimization node for Webpack can be configured with, I don't know, somewhere on the order of like 10 million properties. But the gist of it is, in here, is that we're telling it that we want to split the bundle this time. And specifically, we're telling it to split the bundle in a way that you'll find in lots of blog posts, but again, I want to talk through it. We're telling it to take everything that we might find in node modules and to keep that into a separate bundle called vendor. And this is about the most basic configuration we can do with it. But the interesting thing is what it actually accomplishes when we go through with this. By the way, it is, for any of you who don't present on Zoom normally, it's amazing how much slower things like running Babel are when you're actually sharing on Zoom. I'm continuing to stare at the screen because it's taking about 3 times as long to generate the same code. All right, let's look at these two side by side if we can. So here was our original one. Let's try that again. Here was our original one, and here's our current one. Over on the left-hand side, you'll see that we had a main.js, and that was everything. Now, if I open these up, you'll see that over here there was no sort of separate modules. There's just main.js. Here, you'll see that I now have a main.js and a vendor bundle. What's really interesting about that is that the vendor bundle of the 1.1 megabytes, so in other words, our node modules, is 1.16 of them. And our code for main was 8K. So I can turn these off for right now and just zoom into our main code. And you'll see that this is really just the code that happened to be part of the application. So this is what's here. So in this case now, we've split out the idea of the vendor code from the main code. This is bundling, okay, or the breakdown by bundle. The important part is that if we were to load this now, and again, don't underestimate the value here of this. When we load this, we will see that we are loading the vendor bundle as one piece and then main.js as another, okay? So we have one more dependency that we're loading in here versus when we would have started. The gist of this though is that here, we now are gonna download and bring this piece down. And when we bring this vendor down, it's going to be cached. So if we change again a couple of bytes, if we change things in main.js, the likelihood that somebody needs to re-download this is very small. And again, lots of times the one that gets all of the fanfare is the code splitting, which we will get into. But it's super important to understand that that is probably one of the biggest pieces you can do to actually optimize for your users. Because if your users actually don't have to download, in this case, 99% of the code again, they're going to be much, much faster pulling that from their cache than sending it over the wire. So all of the lazy loading in the world will not make up for how effective it is to just not have them download code that they don't need to see again. Now, here we did something really basic, right? We threw this into this vendors bundle. But I actually just want to show for a second, this thing is really powerful in the different things that we can do. Right now, we're basically saying, just reading this really quickly for you, we're making one vendor group, we're forcing it to be true because Webpack tries to be really smart and look at minimum sizes and stuff. So we're basically saying, hey, no matter what you think, I promise you this is a chunk I want. And we're saying to download it right away, but basically we're saying everything in node modules. This is a very simple configuration by which we optimize things into one side, but we can go really crazy on this. And the point here is to maybe go between the two extremes I'm about to show, right? Right now, we dropped everything into vendor. And that is just the other side of the equation. We took all of our code and dropped it in vendor. But perhaps if we knew that we were unlikely to, for instance, update versions of React every couple of days, maybe we would want to put that there. But if there was a couple of libraries that we changed more frequently or libraries we had internally, we might want to draw those out and leave those be things that the user goes through or downloads. So we can actually go and take this kind of far if we wanted to. In fact, if we go all this way, and I'm giving credit to a gentleman named Dave Gilderson here, who I really like this piece of code that he wrote on his blog. So I want to make sure I gave him credit for that. But if we go all the way that we can here and take this as far as we can, or maybe as far as we should, I'm not sure which, we could actually, using that same syntax, say, you know what? We don't care how many initial requests they're going to be, and we don't care how big the bundle is going to be. Any size is fine. And you know what? For every single thing in node modules, I want you to find the name of the node module, and I want you to make that a package name. If we actually did this, we can go to the other extreme with this same bundle scenario here, which is that we could tell it that we want to split things along every single node module that we happen to find and keep an individual dependency out of those. Now, this is actually kind of interesting because what it's going to mean, Give this a second to build. When we go look at this, we're now going to have a lot of bundles. In fact, if we look, we have a bundle for almost all of the different pieces that we would have found internal to every node module that we'll come across. So in here, we've gone the other way, right? We've said that each of these things is an independent piece, and we would like all these little tiny dependencies, and we'd like to load them up in fairly individually, where we can see React is probably the biggest piece now, but everything else loads in here. And interestingly, when this reloaded in the background, you can see that it's loading up all of these pieces individually. So let's talk about that for a minute though, because this seems like a ridiculous example. And I will admit it is a little ridiculous intentionally, but it's not totally ridiculous. Because if we have lots of dependencies and a lot of them tend to be relatively static where they're not going to move around a whole bunch, then doing this in such a way that we actually load them or let the user individually cache them on their machine potentially, such that when they return, they only load what's new is not a crazy idea. So do I think you should go this far and break everything down to a node module? I would strongly advise no. However, the idea is still valid, right? Which is that we can figure out the level of granularity on how we want to break things down for us and be able to build them. And so while we're about to, and we're going to move the pivot over in a moment to the dynamic code loading, because all of these are still loading up front. The most important thing to understand here is that we have a level of granularity that we can achieve with Webpack and really break things down. And this is where we should start. We should start here. We should figure out what we actually want to make sure is cached and isn't going to change very much on a user, because otherwise we're going to be abusing the dynamic code loading when this is actually an easier technique and probably in the long term better for the user in many cases. Okay, so this was cool. We got a whole bunch of modules. We probably are going to abandon this now because I don't want to manage all these and I don't want to see it in this way. But it is neat to understand that with Webpack, we have a level of configuration that we can take things as crazy as we wanted to and be able to go in. That, though, was the last thing. Oh, actually, I wanted to mention this. If you'll notice so far, I haven't made any code changes. In other words, this code so far and everything that ran and the little to-do app, which would still work the same, need a new to-do app, is all done by changing just configuration. The interesting thing about these sorts of configuration changes or these sorts of bundling issues are that they're just configuration. Because since they're all loaded up front, there's no change required in your code to just shift things around into new bundles. When we get into splitting components, though, and code splitting, we have to treat things a little differently. And that's because in our traditional code, we are used to, whether we use requires or imports or things like this, we're used to seeing something that looks a little like this. We import something from app, and that means it's here. We have it to access now. So we've statically imported it or brought it in, and we have it available to us. And in here, we bring in something from to-do, et cetera, so on and so forth. When we begin doing code splitting, we got to treat things just a little bit differently. And that's because we no longer have something that is just going to be there on startup. Instead, we are acknowledging and in fact asking for something to be presented to the user that is incomplete. We're asking to present something to the user that has some portion of the application. And then under some conditions that we can control, we're going to bring down more of the application as we feel we need it. So in this particular example, and I'm going to start this in the background so I can talk through it while it runs, but in this particular example, we're going to begin bringing things down lazily. And code splitting basically implies some form of lazy loading. So we're going to go into the app here for a moment, and we're going to see that this part is roughly the same. We still have to-dos, we still have other things. Let me go back here. But we're going to now begin doing things that are a little different when we actually get into loading. And we're going to see that as we go along here with these pieces called like lazy button, lazy dialog, lazy to do. So our normal dialog and the pieces that we see would have looked like this. This is a standard React component and piece that we saw. But when we start getting into these additional pieces, we're going to get something that's a little different. And this is intentionally set up to be super slow right now so we can see it. but you'll see that there's actually some delay and some things as pieces load. So let's talk about what that means, because we have to understand two pieces that are thrown around a lot, but aren't actually very hard, but they're thrown around a lot in order to do this. And those two pieces are React Suspense and React Lazy. So let's look at this file really quickly, because this is a small one and we're going to piece it apart line by line. First off, we're going to see that we have this React Lazy call. We're going to see that our import for our to-do is now inlined here somewhere. And that's because this is now, if you not an import statement like here, but it's an import function that we're calling. And when we do this import function, it's actually something that is asking it to go load this particular file when this function runs. Okay, so it's more of a dynamic evaluation. We're asking it to do something. So when we build this back up here, we have suspense, we have to do, we have dynamic import. We absorbed a lot of new concepts all at once, but let's break them down. Import is really defined as the type of thing. It's just basically a function that when invoked, okay, so it's a function that we're going to call, and when invoked with some type of file or technically a module that we want, it is going to go and it's going to return a promise to us. Okay, so import is the type of thing which takes the name of a module and returns a promise. And so that promise, just like we would have anywhere else, is going to eventually resolve itself, hopefully, when things load. So let's take that back a step then. React Lazy is something that takes a function. Now, for anybody who's used any of the modern React hook stuff, this should look a little familiar. Because if we see things like use memo in React, they take a function, okay? And then they take a set of arguments. And here is some code that runs. That was nice of you, VS Code, thank you. Here's some code that runs when some dependencies change. But the important part is it's a factory. So it's a function because we're trying to defer it. We don't want the stuff to adhere to run the moment we load code. We want it to run later when something is invoked. And React Lazy is exactly that type of thing. React Lazy is saying, well, it's nice of you to tell me what this import statement is. But what I'm asking for is you to actually put it in here so that I can know when to do this import. So React Lazy is something that takes a factory and eventually, once that factory is invoked, its job is to resolve it to something that can be a React component. But it's kind of a layer or two removed. So the import statement's going to go load some JavaScript and return a promise, or it's going to start loading some JavaScript and return a promise. The React Lazy is a type of thing that takes a function that returns a promise. And then so React Lazy is going to wait for that promise and then eventually sort of become a component. So that's what the React Lazy does. Let's take a step back now to Suspense. Suspense is a really actually very, very promising API, and there's a lot more in general to it. But let's talk about the basics of why it's important to us right now. React Suspense is something that can take things that are lazy. So things created with React Lazy, for example, but there are others. And it can render something that is a fallback component or something that is on the view that is not your final state until the lazy things are ready. So it's going to substitute, in this case, null renderer, but it's going to substitute something until the lazy things are ready. So these pieces combine together to look at it as the thing that is going to know how to render something until the lazy things are ready. The thing that is going to define the lazy stuff, which is going to create a factory that when it's needed is going to go import something, return it, and then build it all back up. So when we get to this piece here, and when we get to it, what we really have now is we have something that is going to render an application. And that application is now, as opposed to being composed of all the pieces that it had before, it's going to be composed of a to-do still, but it's going to become increasingly lazy. So if we go over here and look, and we start by refreshing this, we'll see that we still have a few different pieces here, but let's watch the order of operations there for a second. You'll notice that button bundle popped in a little later. And that's because the button, in our case here, is what we called our lazy button. And our lazy button is this type of thing that's a React lazy. So what this is really saying is, I want you to go load this once it's needed. In other words, once someone tries to render it. Now, just so we can see it, because it's going to be fast, right now we actually did another little trick, which is to say that since we know this thing just returns a promise, we just use the set timeout to add an extra 2 seconds in here, okay, before it actually resolves the promise. And that's why we can actually see it for just a second, pop in and go from loading to new to do, because the fact that we're intentionally adding like 2 seconds of fake network traffic in there just to make it work. But if we continue to watch what happens here, as we click it, each of these bundles that we need pops in as we navigate to the area of the app that actually uses it. And they won't be loaded until that period of time. Now, the configuration for this is still necessary, but you'll notice the big difference is that we've actually crafted the app a little differently, okay? And this is another reason why these are really, really valid techniques. But we do need to keep in mind that there is overhead in using them and that we have to construct our code differently. So we really want to be clear that it's worth it and we want to do it once we start thinking about it. So over in the Webpack config, most of it is going to be very much the same right now, because we're still making our initial vendor bundle so that we load all those pieces separately. As I mentioned, that's the big part of what we get a win. But then internally, the mere fact that we have all these lazy imports is going to tell Webpack by itself to go off and do some additional work. In fact, every time we see one of these imports, by default, Webpack is going to go off and create a separate bundle for it. This little thing in here is called a magic comment. It's something that Webpack uses. I'm going to undo these for just a moment so we can see the difference of it. So I'm going to lose that one, and we'll lose this one for right now. By default, Webpack mentioned is going to know how to build, and anytime it sees one of these dynamic import statements, it's going to build a module. But by default, it's not really going to have a good way to know what it should name them for us, okay? So by default, if we go through and we get into these different pieces here, Webpack's going to name them things like 1, 2, 3. Very useful, like it only needs a different number to do so, but certainly not great for us to debug things. So while we could do this through config, Webpack supports actually a whole bunch of these magic comment ideas, whereby we can actually tell it little bits of information in comments in our code. So in this case, we've told it we want. So is this a question?
Sure, Kojic.
I had a young family, 4 kids. I had to make a bloody living. All right.
All right. So in the Webpack chunk name, in this case, we have to do, or input, or dialogue. And what that's going to do for us is it's just going to inform Webpack that, hey, when you make this chunk for me, because this is already saying make it, I want you to name it this. And it's just going to help us out so that we can have a little bit better debugging and maybe eventually a little bit better caching so that we see reasonable names when we load things, okay? It does give you one more cool piece of control though, because if you actually knew that, you know, there's never really going to be a time that I load dialogue that I'm not going to load the input right afterwards, you can actually give these the same name and Webpack's going to stick them in the same bundle. Instead of making 2 different bundles out of it, you'll now have one bundle, both called dialogue, where when we actually go to load this up, what we'll see is that we just get the dialogue bundle, which now had the input in it too. So we actually have the ability, as soon as we have an import, we are going to have something that's separate, but we can decide and mix and match for ourselves how much we want those pieces broken down into individual pieces, or how much we want to combine them back and together into units that we think are reasonable. Again, you can actually do that part through configuration and regular expressions and lots of things as well, but it is kind of convenient, honestly, to be able to throw it in here and see, and also when you're looking at the code, debug and know what something's to be expected. Now, this is all loading right now inside of React Lazy, meaning if we can walk through this code for a second, because I want to make sure this part's super clear. When we load the app up, it's going to render app. When app renders, it's going to say, okay, cool, I'm in my function. What do I have to do? Well, I have to render to do. All right, good. It's also going to say I need to render this button, okay? And the button is lazy. So what's going to happen automatically, since it's going to try to render this button, the moment it tries to render this button and it's lazy, it's going to know it needs to load that button. So the fact that we're rendering it on the screen right now, or trying to, is the trigger for that React lazy component to go off and know it should execute that import, okay? Flip side, we could do it differently, meaning if we were just to take this same dynamic import, this one right here, and we were to throw it right up here, let me go back a second here. If we were to take this same import and we were to move them up, so let's just say, well, let me find a better one. We'll take this one. All right, and for whatever reason, we were to say, you know what, we actually want to load input, or we want to import input up here, kind of closer to what we did with these import statements. This is going to mean we don't need to wait now until we start rendering it. The moment this module is referenced, it's going to import it. So this is basically a preloading step. So now what you'll see is that that input loaded right off the bat. And that is because it didn't need to wait to render it, to render input, because imports referenced at the base module. So the input is being pulled in right away. So the difference between this import being here and this import being in this lazy function is the determination of when it loads. Here, the moment this whole thing is referenced, not rendered, but referenced, it needs to load it. Here, there's an extra layer of indirection. So when the component is actually referenced, it builds it out. So being able to do that and to be able to manage the suspense side is quite cool. The suspense, by the way, is what's giving us that effect of saying loading, and then it's here, because that's our fallback, okay? That's our suspense basically being able to say, I need some sort of hook to wait for me to be able to render something until the rest of the code is ready. So you can think about suspense is really ultimately just being something that is waiting and rendering an alternative thing until our lazy content's ready. Now, they're not one per one, because one of the questions often is that ends up being when people start playing with them is, well, why do I have to make this lazy thing and then put it in suspense? And it's not obvious for like most of the examples we'll see until we do something like this. Suspense doesn't have to take one lazy thing. Suspense can take a whole bunch of lazy things. Hopefully, my headset just beeped there, so hopefully you can all still hear me. But the suspense can take a whole bunch of lazy things and render them all together as one piece, meaning once it's all ready, they'll all render together, but it will also show the loading until they're all there. So to that end, as we're going through any of these sorts of pieces, the important part of the important understanding is that the React suspense sort of version of the world is going to allow us to have that loading screen until a whole bunch of things appear. Okay, so when we go through right now, we have our lazy button inside of suspense, inside of these other things. The important part again is just the takeaway that I want you to come up with is that these things are multiples. Okay, so we have lots and lots of things. We'll wait until they're all ready. Once they're all ready, we can go forward. It understands even if there was 200 things it needs to do, it can manage that. Okay, so here now in what we've ended up with is we have, go forward. Yeah, that's fine. Let's do this instead. Okay, so what we've ended up with here is that we have both the vendor thing, so the thing we showed first rendering or using, so we have stuck all of our vendor code in there. We still have our little main.js, which is our main code, and then we now have bundle per bundle for each one of the components that we needed that's only loaded when needed. This would totally be overkill for an app this way, but again, and you incidentally, probably a terrible idea, right? Because how many people are going to use the to-do app and never click that button? So it probably doesn't make a whole lot of sense to not render it. But for places where somebody isn't going to follow every path, this can be super useful. And when we look at what's actually happening internal to the React side for these same sorts of things, we'll see that React has taken the whole thing, which was 1.17 meg, and 1.16 of it went into the vendor bundle, and then about 10K is in main, and then each of these little pieces is broken down into what it is in terms of what we actually ended up using. And so over here, we can see if we only wanted to, for instance, look at what's in to-do, that's exactly what's in to-do. It's to-do.js. It has no external dependencies because the external dependencies it did have are all in their own modules. So each piece that we want to look at here are all so small because of the fact that all of their dependencies are external. Okay. And so here you can see main.js had some CSS styles, which now, by the way, in this graph, the size of the individual items is actually relative to their code size. So our CSS is the largest part of main.js right now. So this is that piece, and then it's telling you over here, by the way, I also have references to these other pieces, but app and lazy and all these pieces are broken out into different pieces from there. All right, let's look at one other thing real quick, and then we'll talk a little bit if there's some questions I can answer in terms of this. But Suspense right now and lazy in this way don't work for anybody who might be doing server-side rendering, okay? So in the meantime, there is one other piece that is both potentially useful if you want to use it, but also is your solution if you're doing server-side rendering, which is something called Loadable Component. Loadable Component is very much the same idea, but the gist of Loadable Component is that Loadable Components basically allow you to manage some of these pieces internal to the fallbacks. So what a Loadable Component does for you, it's this library called Loadable Component, and it's endorsed by the React team as well. And you'll notice it's very similar to the stuff we were doing before. However, instead of directly calling lazy, instead of directly calling things like this, we call something called loadable. And right inside of that loadable, we give it the import statement we want, and then we give it whatever we want as a fallback, okay? And that import statement plus that fallback just gets built into one component. Loadable is kind of cool in the short term, and it's requisite basically if you want your code to be able to do server-side rendering as well. But it's really doing the same thing, and it's wrapping internally that suspense piece along with that lazy piece for you. There's no real reason to do them if you can manage that suspense and the lazy on your own and if you're in the browser. But since the suspense and lazy don't work the same way on the server, Loadable basically aliases those so that when you're in a server environment, it can just load them up. The reason I mostly wanted to show you this is that a good portion of the code, if you go to try and Google for this and figure out how to work with this on your own, is going to use this or a similar library. And there's a couple of reasons. First, before some of the latest releases of React, you really did need more components to handle lazy loading. It had to do more behind the scenes for you and had to do some trickery. So you couldn't directly use suspense and lazy. You can now. Second, again, if you're on a server side, it can be very confusing why all of a sudden your code doesn't work the same. And so people like that, or like this loadable library, are basically out there doing that work for you. So to be clear, if you're going to see this and you do see something like this as far as loadable goes, just read this to yourself as the same thing. Loadable says I need to do a lazy import and I need to do a suspense fallback. And that is the same code. If I go look at that piece next to each other and come back here to the other one, we have a lazy import with a fallback. And here we just happen to have it in one function, a lazy import with a fallback. It's going to work exactly the same. It's not going to do anything really different. It's just wrapped up into one component that is allowing you to do some of those things in one piece. There are some other things that kind of go into this and some other parts that you can kind of build together. But the gist is basically the same. It's how do we break the pieces? Where do we create the seams? What part do we put into the idea that it's a chunk of bundle that maybe always gets loaded, but it's cached? What chunk do we really want to load per user? And if we think about the trade-offs, and this is really, really, really important for just a moment to understand, there's probably 2 or 3 things that we think about in terms of when to load something for a user. If we make the user wait for a bunch of stuff up front, that's a pretty bad experience, right? Like if we made them wait for a bunch of stuff, because ultimately they're sitting around and just waiting for something to load before they can use the app. All right, so not a great experience. I think we can agree. But the other side is maybe just as bad or close, which is that the user clicks something and then we make them wait a whole bunch of time at the moment when they finally decided they wanted to do something before they can do it. So keep in mind that these are the two polar opposites. And a lot of the application is going to have to fall somewhere in between. We can do things like optimistic loading. We can do things that allow us to load in idle time in different parts along this. And there's a spectrum of things. But keep in mind that most of the examples you're going to find are here or here, and neither of those is exactly perfect. Almost everything is a spectrum of somewhere in between, because we neither want the user to wait for no reason, nor do we want them to have to wait for a very long time when they actually decided they want to do something. Okay, so these are the techniques. They're the Legos, right? These are the building blocks that we can build up and we can build something on top of, but that's what they are. They're Legos. They're how we bring things together and how we use these pieces. So if you take anything away from it, it's this. Loading on the client side or breaking things up is either a decision about what we load or what we split into separate code, but always load, and that's basically breaking bundles up. Or what we split into the individual pieces of code and optionally load. And then as it sounds, once we decide optionally load, then we have to begin to break things down as to the question of when. When do we load it? Do we load it when it's clicked on and needed? Do we load it when a module is referenced? That would be the difference of me showing you the import up top or in a lazy component. And then how do we do it? The hows here that were important are the import, and specifically this import function, which is called a dynamic import. Again, import function returns a promise. So you can actually use it in much the same way as you use any other sort of promise infrastructure, but it returns a promise. The React lazy, just a function that works just like use memo, expects a function that when invoked will return a promise. That's the chain together. Why do we use that when the rest is just a promise? Well, because it gives us one other little advantage. It says, hey, I'm going to do this import when somebody references me. So React.lazy's whole job in life is to really just kind of sit around and wait for the moment that it's about to be put on the screen, and at that moment know that it's supposed to finally fire that import. And then Suspense basically says, I understand there's a bunch of lazy things in the world. I promise you I will show something else to this user until all of your lazy things are ready. Those are the pieces that fall to client side. So those are the pivots. Those are the major pieces that come together. Why don't you let me know, since I felt like I have talked for a very long time with no questions, if you all have any questions I can answer.
I kind of have, I'm a beginner with React, so I'm understanding this from the standpoint of like you have your import statements at the top, you know, of your JS file, and essentially from what I'm understanding and gathering from this lazy lazy function is that you can elect to not put something in your initial import statements upon, you know, React initially rendering, to save like that period of time in which it's going to initially load. But then, you know, you're not going to get away from it actually having to load. You're just going to prioritize when it loads later.
I think that's a very good summary. So here's your gist, right? Anything up here is basically saying, and this is not 100% right, but I think it's a good mental model, okay? Anything you put up here with one of these static import statements is saying, this is a requirement before you can do anything in this module. They have to be here, okay? Anything that you put in one of these dynamic imports is saying, I need you to load this before whatever is going to happen next. All right. Okay. And so you are 100% right that one way or another, if they click through this, you're going to need it. What we're altering is when we get it and when we bring it together, right? So up here, we're saying before we even get here, it needs to be here. Down here with these other syntaxes, and I'm going to go back to this other one because it's a little cleaner to look at, to me at least. Down here, or this other one was basically just saying, and we're going to do that for a second because it'll be super clean to look at, is we're saying here, you know what? When somebody wants lazy button, go load button. And so we're basically just deferring when we do it. Now there's a penalty, but it's maybe an okay one, right? The penalty is now when somebody wants it, we have to take a little bit longer to load it. And so that can be a penalty if it's a really big thing. But the advantage is that if we have a lot of these things, we don't make somebody sit around and wait to load a bunch of stuff that maybe they never are planning on using this in application.
So to give it a different example, like that would allow like a little bit more, like something that would have a little bit more weight to it than just like a to-do app.
Yep.
So in essence, like if I had like an e-commerce site or whatever, or I had a site that was like saving like profile information, on the page when it renders the person's profile, like I wouldn't need the form for them to change their address. You know, I wouldn't need that to like load or render, you know, if that's not something they're going to frequently be using as a feature. But on their page, they do need the option to like change their address.
Yeah. So let me give you an actual real world one from something we do, okay? We do a lot of big applications that actually help run hospitals in some cases. And as you can imagine, a whole bunch of different people who have very different roles in the world log into that same app in a hospital. And when a doctor sits down and logs into that, they need a whole different set of features and at a different period of time than somebody who's doing registration when you come in the door and has to admit you to the hospital.
Mm-hmm.
So there's no use in making the registration clerk download all of the clinical stuff. And there's no use making the clinical person download all the registration stuff. So instead, if we can download on demand what they actually need, we're making both of their experiences better, right? So that's some place that we real world are trying to use this. But I like your idea too, and what you'd said about the e-commerce. What I would say is think about the whole idea of the My Account section, right?
Mm-hmm.
Like you're browsing, you're there to go to Amazon and you're going to order something. You may go through that ordering workflow, but maybe it's only 1 out of every 10 times you do that you actually click into the section to go see your old orders. So maybe if we can defer all that code that is about seeing our old orders or reviewing things or buy again or anything else, if we can defer all that over there and only bring it down if you need it, then we're maybe giving everyone a better experience.
Okay. Thank you.
Yeah, absolutely.
What's the downside in that first example where you did the bundle split on every like package?
Yeah.
What's the, like, it seems to me like if you want to split, that seems easy, right? You just use that code and now everything's diced into these things. What's the downside to having too many?
So this is a little debatable, and I'll be honest. So there's an answer, and then there's all the real details behind the answer. So stick with me on this one, all right? First of all, if you're in an older web server, you're making more HTTP requests to get each one of those. So you're making more requests. Now that is largely alleviated with newer HTTP, like HTTP2, because you can actually have multiple requests come over the same channel, okay? So you make one request and lots of stuff comes down. It is potentially, though, more serial and individual pieces you pull down, but I'll be honest, there are times that I think it's a very reasonable strategy. There are times that I actually don't think it's that ridiculous, but it is the furthest example I could find that way for you. So maybe if you take it that way, it is that part of it. But to be honest, I think a part of it might be that you may not need to break it down that much because it's likely that things probably change together. It's likely that if you update a version of React, you probably are going to take all the React-based packages and probably update them at once. So maybe you don't need to keep them as individual pieces, right? So it just might be a little bit of overkill, but is it the worst thing ever? No, you could do much worse things than that. Fair enough?
Yeah, it just seems easy. You know, you just put that in my code, now I'm done.
Yeah, and you know what, here's the thing. There would be one more thing I didn't show you in here, and that's okay. One more thing that you would want to do is that right now you've seen me naming everything's in really static names. Webpack can insert a hash into the name as well. And that would be the one more thing you want to do because you want to make sure you cache bust. Because at some point in time, if I change one of those dependencies, I sure want to make sure someone gets the new one. But other than that, it would be legit and it would work just fine.